In section 4.2a, we're going to be working with the standard form of a quadratic function. We've already looked at the vertex form of a quadratic function, so what we need to do is look at some other varieties that we might see the same graph. It's going to make that same parabola shape, so that should be familiar, but we're going to figure out where the vertex and line of symmetry is in a little bit different way. So this is the standard form for a quadratic function. Y equals ax squared plus bx plus c. Now the a, b, and c are going to be numbers. They can be fractions, they could be decimals, they could be integers. The a is the only one that can't be 0, because if the a was 0, then it would not be quadratic anymore, because we wouldn't have an x squared term. The b could be 0, and the c could be 0, and we'd still have a parabola. So let's talk about what each of these numbers tells you. We'll use them all eventually. But for now, I want to talk about this number that's right here. Now, when you looked at vertex form, remember it had y equals a parenthesis x minus h squared parenthesis plus k, and that a that was in front told you if there was a stretch or a compression and whether it reflected over the x-axis. And this is the same a. So this number here is going to tell you if there is a stretch or compression. Remember, it's a stretch if a is bigger than 1. It's a compression if a is between 0 and 1. And also reflection over the x-axis if it is negative. Now we'll get to what all the other numbers are going to be used for here in a little bit. The line of symmetry. Remember, the line of symmetry is a vertical line that goes through the vertex of the parabola. And remember, it is also the x value of the vertex. So we found that line of symmetry differently when we had vertex form. When we have standard form, we're going to find it by doing x equals the opposite of b divided by 2a. So this number b that's right here could be positive or negative, and we're going to do the opposite of it and then divide by 2 times a to get the line of symmetry. I'm going to work an example over to the side with all of the information we have. So we'll have y equals negative 3x squared minus 6x plus 1. So in my example here, the value of a is negative 3, which tells us we have a stretch and we're reflecting over the x-axis. The value of b is the number in front of x, that's negative 6, and the value of c is 1. So let's figure out our line of symmetry. It would be x equals, I'll write LOS for line of symmetry, x equals the opposite of b. B was negative 6, so that'll be positive 6 divided by 2 times a, so 2 times negative 3, which is going to be 6 divided by negative 6. So my line of symmetry will be x equals negative 1. Make sure that you put that in an equation. It has to say x equals negative 1, or it won't be a line. For the vertex, remember we said the line of symmetry is the x value of the vertex, so the x value is going to be opposite of b divided by 2a that we get from here. And then to get the y value, what we're going to do is we're going to have to substitute that number in to our equation and work out the y value. So we will sub opposite b over 2a into the equation for the x value to get the y value. I should have made that parenthesis a little bit bigger. So let's do that with our example. So our x value is -1. So what we're going to do is we're going to go y equals, and I'm going to use this equation here, -3. I'm going to replace the x with a parenthesis with -1 in it. So -3 times parenthesis -1 squared minus 6 parenthesis -1 plus 1. Then I'm going to keep working through this. So that's y equals -1 squared would be +1. +1 times -3 is -3. -6 times -1 is +6. And then plus 1. One thing that you should always notice is that this term here and this term here, one will be twice as big, and they are going to have opposite signs. So that's a good indication that you've done things correctly, because 3 times 2 gives me 6, and those are opposite signs. So you'll want to watch for that as you're working. And then we're going to add these together. -3 plus 6 is 3, plus 1 is 4. And then the vertex always goes in an ordered pair. The x-coordinate was -1, and the y-coordinate is 4. So there's the vertex of our parabola. The pattern to graph these parabolas is going to be the same as it was when you were working with vertex form. So remember, the general pattern was to go over 1, up 1, and then you go back to your vertex and you go over 2, up 4, and then go back to the vertex again, go over 3, up 9. Now remember that number out in front, that A? We have to multiply our ups times whatever number is out in front. So I'm just going to put times A, times A, times A. So on our graph, the value of A was -3. So for my pattern, I'll go over 1, up 1, times -3, over 2, up 4, times -3, over 3, up 9, times -3. So my pattern is actually going to be that I will go over 1, and then I don't really go up by -3. What I'm really doing is moving down 3, and then over 2, and down 12, over 3, and down 27. Now, I won't be able to fit all of those points on a graph, but I'll fit what I can on there and go from there. So here's my pattern to graph for this parabola. Domain and range. Remember, domain is all the x values that our function is defined for, and for every single parabola, the domain is that x is greater than infinity and less than, greater than -infinity, less than +infinity. So that's all real numbers. And the range is going to depend on what our parabola looks like. If your parabola opens up, then your vertex is going to be the ordered pair x, comma, a minimum value. If your parabola opens down, then your vertex is going to be an x value, comma, a maximum y value. So if your parabola opens up, then the range is going to be that y is greater than or equal to whatever your minimum value is, because all of the y values are either that number or higher. If your parabola opens down, then the range is going to be that the y values are less than or equal to whatever your maximum value is, because that's the highest y, and all the other y values are lower than that. For the function that we're working with, remember our function opens down, so the domain will always be negative infinity is less than x is less than infinity. And since our parabola opens down, this number 4 here is our maximum value. So it will be y is less than or equal to 4. The y-intercept for this function, to find the y-intercept, what we're going to do is we're going to substitute in 0 for x. And if you think about this standard form, and I put in 0 for this x and 0 for this x, then I'll have y equals a times 0 squared plus b times 0 plus c, which gives me y equals 0 plus 0 plus c, or in other words, y equals c. So the y-intercept in standard form is going to be 0, comma, c. So I think I'll go ahead and label that up here, that this is the y-intercept. Remember that your intercepts always should be listed as an ordered pair. For our function, the value of c was 1, so our y-intercept will be at 0, 1. Now I do want to look at an application of standard form. So we'll have to write this out. The revenue for a feather company is given by the equation R equals negative 2.5 p squared plus 500p, where p is the price of feathers. Now I want to ask a couple of questions. One question is, I want to know what price maximizes revenue. And then I also want to know what is the maximum revenue. Now, when you first look at this problem, you might think, oh my gosh, I have no idea how to solve this. So what we're going to do is kind of look at the equation and think about what shape that's going to make. So this particular function is a quadratic equation. And it's in standard form, it just has plus 0 at the end. So I have r is like my y value, and p is like my x value. So it's like y equals a x squared plus b x plus c. So this is a quadratic function in standard form. So it's like y equals ax squared plus bx plus c, except for it's r equals negative 2.5 p squared plus 500 p plus 0. Now we just talked about what shape that makes and what each of those numbers helps us figure out. And remember that that number that's out in front, the a, tells us if we have a stretch or compression and also if we are going to open up or open down. That negative number tells me that the graph is going to open down like this because it's reflected over the x-axis. So since the graph looks like this, I can find the maximum point right here at the vertex. So this right here is going to be, remember, x comma the maximum value. Now, in my function, I don't have x's and y's. I have r's and p's. Since the r is in the same spot as the y, this y-coordinate is going to be revenue. And since the x is in the same spot as the p, this x-coordinate is going to be price. So every ordered pair on my graph is going to have an x value that represents the price and a y value that represents the revenue. Well, if I'm looking for the maximum revenue, because it says what price maximizes revenue, that maximum revenue is going to happen at the vertex. Now we just coincidentally figured out how to find the vertex on our previous page. So just as a reminder, remember to find the vertex, we do opposite b over 2a, and then we substitute that into the equation to get the y-coordinate. So, how do we find the vertex? For the x-coordinate, we do opposite b divided by 2a. For the y-coordinate, we plug it in. Now this time we don't have x actually. What we have instead of x is the letter p. So instead of doing x equals opposite b over 2a, we are going to do p equals opposite b divided by 2a. So in our equation, the a number is negative 2.5, the b number is 500, the c number is 0. So for our vertex, we're going to have p equals the opposite of b, so negative 500, divided by 2 times a, which was negative 2.5. So that's negative 500 divided by negative 5, which is 100. Now to get our y-coordinate, we're going to substitute in 100 in our function. So we'll take r equals negative 2.5 p squared plus 500 p, and we're going to replace the p with the 100. So we'll have r equals negative 2.5 parenthesis 100 squared plus 500 times 100. So that's r equals negative 2.5 times 10,000 plus 500 times 100. So r equals negative 25,000 plus 50,000. Okay, now remember a little bit ago I told you that when you're substituting in to find your vertex, this first number and the second number, one will be twice as big and they should have opposite signs. So we're on the right track here. So then we'll add those numbers and we get R equals 25,000. So our vertex is going to be 100, 25,000. Now, thinking back to our graph, this spot on the graph is the highest y value. Since the y values were revenue, it's going to be the highest revenue. The x-coordinate is going to be the price that will give us the highest revenue. So based on our vertex being at 125,000, that tells me that the maximum revenue is going to be 25,000, and the price of feathers is going to be the 100. So now I can answer my question, what price maximizes revenue? Well, that was the price of the feathers of $100. And what is the maximum revenue? That was the y-coordinate of the vertex, so $25,000.